Now, welcome to chapter 4. So, in the course, we have talked about the development of number in kids. We also talked about development of different kinds of numbers, so including decimals and fractions and percent. In the last chapter, in chapter 3, we talked about addition and subtraction. And now we're going to look at multiplication. Now, multiplication is just as related to division as subtraction is to addition, but we're going to take a look at multiplication first and then follow that through with division. The primary way that we'll look at division is through missing factor. So with multiplication, one of the ways that the students begin to understand multiplication or begin to become familiar with multiplicative contexts is by looking at groups. So, for example, anytime we see 2 times 3, we can say that that's 2 groups of 3 items. So the first number is the number of groups, and the second number is the number in each group. So 2 groups of 3 in each group. So that's the way that this textbook introduces it as well. Number of groups times the number in each group. And the result, the product, is the total number in all of the groups. So people do get quite worked up about the fact, the order of this 2 times 3, that 2 times 3 is 2 groups of 3, but not 3 groups of 2. Now, in North America, it's 2 groups of 3. It's interesting because in Europe or in England, if somebody's told you what is 2 times 3, they will actually tell you that has to be 3 groups of 2, which is somewhat ironic because on both sides of the ocean, people get quite worked up about it. Now, you will see some textbooks that are very, very rigid in their definition of groups or definition of multiplication. I try to stay away from that controversy because very quickly, no matter how you define multiplication, you will get into a situation where kids will understand that 2 groups of 3 is the same as 3 groups of 2, and they will not see this as an issue. So this getting worked up about something that is very temporary is, to me, seems to be kind of a waste of energy. So, but I'm going to talk through this as if we are in North America, which we are, and as if we're defining this as the first factor. The first factor is the number of groups. The second factor is the number in each group. And then the product is the number, the total number in all the groups. So, for example, if we're looking at the multiplication at the ladybugs here, explain why you can determine the number of ladybugs in the following picture by multiplying. Well, we could look at this as 5 groups of 8. So this could be 5 times 8. This could also be, if we get rid of those, we could also see this as 8 groups of 5. 8 groups of 5. We could also see this as, I don't know if you can catch this one, or if you looked at that initially, but we have 4 groups of 10. There are lots of different ways that we can view this. We can look at groups of 4. Right, so there will be 10 groups of 4, etc., etc. So there are lots of different ways that we can view this particular array as multiplication. Now, for those who get very sticky about the order of the factors, will also sometimes get sticky about which of the dimensions of this array, and this rectangular setup is called a rectangular array, represents which multiplication. So I think we all agree that we have 5 rows of 8 columns. Now, the group of educators that are very sticky about the order in which, or the way that this is written, we'll say that that's 5 times 8, 5 groups of 8, or 5 rows of 8 ladybugs. And they will say that if a child writes 8 times 5, that is not what that particular array represents. That it is equivalent to 8 times 5, but that is because of the commutative property, not because of the way that it is displayed. But nonetheless, I think just like with the previous material in the course, we're going to adopt the sense of allowing different solutions and different ways of thinking, and a sense of flexibility. So hopefully that is okay with everybody here. And then you'll be able to adapt to your curriculum once you get into teaching. So now we're asked to identify which of these situations, where the groups are with this situation. So for example, Eva's puppy weighs 9 pounds. Micah's puppy weighs 4 times as much as Eva's puppy. How much does Micah's puppy weigh? Draw a strip diagram for this problem and use it to help explain how to solve the problem, and write the corresponding equation. So if Eva's puppy is 9 pounds, this is Eva's, and Micah's puppy is 4 times as much as Eva's puppy. So kids will fairly early understand that what we're dealing with is actually 4 copies of Eva's puppy, or 4 groups of 9 pounds. Do you see how that could be 4 groups of 9 pounds? So if we were to write a multiplication statement, it would be 4 times 9. All right. So, or if you want an equation, so this is the multiplication statement. If you want an equation, then Micah's puppy is 4 times Eva's puppy's weight. So let's try number 3. Fran has 3 pairs of pants, 1, 2, and 3, that coordinate perfectly with 4 different shirts. How many different outfits consisting of a pair of pants and a shirt can Fran make from these clothes? Apply the definition of multiplication. Explain why you can solve this problem with multiplication, and write the corresponding equation. Okay, so there are a number of ways that kids generally solve problems like this. So there's a something called a multiplication tree, where Fran is standing in front of the closet, and she comes up and she has a choice of 3 pants. So let's say she chose the first pair of pants, then she has a choice of 3 shirts. But if she chose the second pair of pants, she would still have that same choice for the shirts. And if she chose the third pair of pants again, she would have that same choice. So do you see a multiplication here? Do you see in this tree 3 groups of 4? Right, so it'd be 3 groups of 4, or 3 times 4. Right, so we would have the number of outfits equals 3 times 4. Another way that the same problem can be represented is using something like a table. So for example, we would have 1, 2, 3, these are your pants, and a choice of A, B, C, or D shirt. So if we're looking at a table here, then we would be able to say that this cell here represents pants 1 and shirt A. This would be 1B, 1C, and 1D. And then this cell would be pants 2, but shirt A, and then 2B, 2C, and 2D. So this one is pants 2 and shirt D. And then the same thing in the bottom. So when we're looking at 3 groups of 4 here, we see that there are 3 groups of 4 potential outfits. 3 groups of 4. All right. So let's take a look at the next one. If 1 meter of a rope weighs 9 grams, how much do 7 meters of the same kind of rope weigh? Apply the definition of multiplication to explain why you can solve this problem with multiplication and write a corresponding equation. So if we have 1 meter of rope is 9 grams. So 7 meters of the same rope, so 1, 2, 3, 4, 5, 6, 7, right? So how much would those weigh? And do you agree that it would be 9 grams, another 9 grams, another 9 grams, and so on? So there would be 7 groups of 9 grams. So 7 meters of 7 grams per meter is going to be 7 groups times of 9 grams each. So again, we can see this as a multiplication. Number 5, a piece of rope is 4 feet long and weighs 1 pound. Then how long is a piece of rope of the same type that weighs 7 pounds? So if it's 4 feet long, 4 feet long is 1 pound. 1 pound. How long is a piece of rope of the same type that weighs 7 pounds? So if this is 1 pound, don't we need 7 of these 1 pounds? So I probably drew it a little too big. So let's say 1 pound is 4 feet. All right, this is 1 pound. Is 4 feet. Now, how long is a piece of rope of the same type that weighs 7 pounds? So 1, 2, 3, 4, 5, 6, 7. And they're each 4 feet in here. So do you see that that would be 7 times 4? So 7 pounds, 4 feet each. 7 groups of 4. Number 6, if you have 6 pairs of gloves, 1 pair in each of these colors, red, blue, yellow, and green, orange, and purple, each pair consists of a left glove and a right glove. Write a 2 times 6 word problem that uses the context. So 2 groups of 6 equals what? So one of the questions could be, how many so if we have 6 pairs of gloves and 1 pair in each of these colors, so you would have, what is the total number of gloves, right? Of each of the left and right gloves of each of the colors. Because 2 groups, this could be left and right, and this would be all colors. Okay, so you could say, how many total gloves are there? All right, and then we have, if we have 6 times 6, so we need 6 groups of 6 gloves each. Okay, so you could say, so we need to have potentially a choice of 6 and then another choice of 6. We could say, so if you choose the left glove to be one of the colors and the right glove to be one of the colors, how many different pairs of gloves could you have, right? So this would be different pairs of gloves. Okay, so you see that the context in each one of these problems is quite different. So we have a situation with Eva's puppy and Micah's puppy, where we're using a strip diagram, and we have Micah's puppy is 4 times as much as Eva's puppy. We have a situation with number 3, where we have combinations of things. We have a situation where in 4 and 5, where we know that a certain amount is has a certain measurement, and we want to have 7 times that amount. And then number 6 actually asks you for the question. It asks you to write the question. So sorry that this is sideways, but this is an example of, or a table of the three different contexts for multiplication and in a sense division as well. So for example, we have, just like with addition and subtraction, we had add to, take from, put together, take apart, and compare. We have different groups here. So here there are equal groups, array and area, and compare. So equal groups are situations, things like there are 3 bags with 6 plums in each bag. How many plums are there in all? There are 3 rows of apples with 6, oh, I'm sorry. If 18 plums are shared equally into 3 bags, then how many plums will be in each bag? You see that there are groups or bags of plums, or and you have 2 things. You have the group size, which is 6 plums in each bag here, or the unknown, how many plums in each bag. You have the number of groups, number of bags. So we have 3 bags, 3 bags. And then we have the total number. So there in all, how many there in all? 18 plums there in all. So we have those 3 things, and we may not know any one of those 3 things. So the first one is the product is unknown. So we don't know how many in all. The second is the group size is unknown, and we don't know how many groups we have. Oh, so how many in each group. And then this one is the number of groups unknown. So with a multiplication, the multiplication context really deal with this first set, the unknown product. The others are really dealing with a missing factor, which means that we're talking about division. And we'll get back to those contexts in a little bit. Okay. So 4B is not a core activity, but it is a really good one to take a look at. But we will go through 4C next.